Now in this video we have a comparator circuit using an LM358 op amp, one of the two of them. So we set our reference voltage with the trim pot, and our signal is actually going to come from a light dependent resistor voltage divider right here. So if it's dark enough, then we have a low output. If it's bright enough, we have a high output, and since it's adjustable, I just dimmed the lamp a little bit and that was enough to set it low. So anything darker, it's going to be low, and anything brighter, this is the second brightest from the lowest, I should say. It's not the lowest, one above it, and I can keep going brighter, and there you can see that the output stays high. So I'm going to tick this down 2. Let's do 3. There we go. 3. So I think this is where we had that that cutoff point. If I go any darker, it'll go low. So I'm just going to turn the trim pot now. And so at this point now, it's low, where it was high before. And I got the lamp at the brightest setting right there. So you can see at a kind of a lower setting, we're a little in between, something is going on. And so maybe stray signals are able to bounce it at that point right there. So now we come to our schematic. The trim pot is the more fixed voltage. You just adjust it once in a while, whereas that's responding to changes in the lights all the time. And so we can set it down to 0 volts up to 5 volts, wherever we need to. We just did a visual observation in this video. So we didn't worry about the exact voltages, just where I had to turn the trim pot to get the desired result. But up here we have our signal. So this is going to compare. It's an op amp, but there's no positive or negative feedback, so it's simply a comparator. And when the voltage goes higher, since this is the non-inverting input, that means there's more light falling on it. And as we saw before, when it was brighter, then the output was high. So higher voltage, high output, you get about 4 volts out right there. But that's the basic current path right there. Always make sure you power the op amp, even if you don't see them on the schematic. Sometimes they don't include them. Now, when it got darker, so that was kind of like the light dependent resistor doesn't exist. Before, it was the light dependent resistor was conducting better, kind of pushing that one out of the way. When it gets darker, this one kind of gets pushed out of the way, and the voltage goes down. It sees 0 volts more easily, gets to a lower voltage. And again, it's the non-inverting input right there. And so when this voltage is lower than what we set there, then we have a low output right there. So current path goes there. Blue LED lights up. It does connect to ground pretty well right there. One thing to note is on the physical component, the plus is below the minus, the 2 inputs right there. On the schematic, they could be in either spot, whatever helps to draw it, basically. And so make sure you pay attention to that. Our connection here is going to be below our connection there on the physical component. And that brings us to our circuit. So positive supply to pin number 8 up there, VCC, negative supply to pin 4. I didn't show the pin layout earlier. Here is the other op amp on this integrated circuit. Output, inverting input, non-inverting input. Same over here, other than it's shuffled up one. So you can see output going to the LEDs, and inverted input minus coming to the trim pot where we get our signal. So it has 5 volts across it. With the wiper, we can tap into a voltage anywhere between 1 and 5 volts. Not meant to provide power though, just a signal. These inputs just look at voltage. They don't draw any current in or out. Then, as I said before, light dependent resistor is to the positive supply. 10K resistor to the negative supply. So it doesn't conduct as well when I cover it. So that lowered the voltage, and we have a low output. Now it's conducting better, now that it's getting more light. And we have a high output, as we said before. So if you're not familiar with that, when the output is high, that's as close to 5 volts as it can get. These op amps tend to drop about 1 volt or so. Long lead anode, short lead cathode, and then 220 ohm resistor. Red LEDs don't get as bright as blue LEDs, so I got a lower value resistor, so more current will flow. Which brings us to the blue LED. So when it's lit up, as we talked about before, output's connected to ground pretty well. So you can see that path there. We got a more positive 1000 ohm resistor because it is a brighter LED just naturally. Long lead anode, short lead cathode to the output. So when it is blue lit up there, since we came from positive, we have to go to ground, and it connects to ground pretty well right there. So in any case, that's it for this circuit. Hope you enjoyed.